So I finished building the first part of the 8-bit computer, and what you're seeing here is the clock circuit or the clock module. So the clock is a very integral part of a computer, and it's the one that keeps the computer in synchronous speed. You can have a faster clock and a slower clock. As a matter of fact, if you look at towards the left part of this circuit, at this part here we have a variable resistor which I can be able to vary to increase the speed and decrease the speed of the computer. So watch this LED as I adjust the speed of the computer and as I reduce the speed of the clock. So the clock generally controls the speed of how the computer will be processing, and the clock is very important for a computer, and that is the reason why I've started with the clock. So this video will just be an introduction and a general explanation of how I built the clock. I will step by step move from the left hand side, gradually coming to the right hand side of this circuit. So to begin with, we are going to start with an introduction of what really an 8-bit computer is, just to give you an idea of when it was started and how far we are right now. So 8-bit computers came into light in the 1970s, and one good example was the Apple II, which was a very simple to use computer. And even though it is an 8-bit computer, back then it was regarded as a very fast computer. And gradually we came to the 16-bit, 32-bit, and the 64-bit. The computer you're using to watch this video most probably is a 32-bit computer, or most probably is a 64-bit computer, as the 2-bit computers are slowly being phased out. So with that information, we can be able to begin with this circuit. So the clock module of a computer generally for this project can be divided into 3 main parts. This part, and this part. What I mean is the clock part or the clock module has a very core component that is called the 555 timer, which can be held in 3 states. That is a stable state, monostable, and bistable. In a stable state means that it keeps alternating between 1, 0 or between on and off. The monostable, it can only be in one state at a specific time. That is either on or off. And in bistable, it can hold between the 2 states. So we're going to begin with explaining how this clock works. This is the NE555 timer. It's a very crucial component of the clock circuit. I have used this part here, this part, and also this part. That is what I've just shown you before. They are stable, monostable, and bistable. So starting with the monostable part, with the astable part, this is where we are going to begin our clock. In the astable, if you look at this clock here, or this timer here, the output of the 555 timer is a pin 3, which is this pin. And if you look closely, the pin has its output to this LED. So what this pin is doing, the output is taken to this LED. By design, it could be better if I could have put the LED closer here or here, but I wanted it to be here so that we can be able to clearly see the difference between the 3 states of the clock. So this first state is called the astable state, whereby when this pin or when this chip is turned on, it will keep changing between on and off all the time. That is called astable, because the output is connected to here. A good explanation of how the the 555 timer works is very easy to understand. Just keeps varying the voltages. The output will also keep fluctuating. You can get the manual for the 555 timer and be able to understand how this state comes about. Now the second state is the monostable. The monostable has only one state. It's only stable in one state. So this is the chip that controls the monostable state. If you look at this chip, pin number 3 is this white wire. It goes like this, and then it goes to this LED. So for this 555 timer, I've connected this tag switch, whereby if I press this switch, the LED comes on. I release, the LED goes off, meaning that it is only stable in the on position, like that. Good. Now the third state is a bistable, and the bistable, it's this chip, and this 555 timer, the output is this yellow wire which goes to this LED. Now when you call it, the reason why we are calling it bistable is it can operate either. So therefore we really don't need a switch for that. So therefore at this stage here, and I can try turning off the light for you to see clearly. This is how it is an on position, meaning that it is stable in this on position. Now that is generally what all these LEDs or all these states work. So moving on from this section here all the way till the end, which is a combination of all these 3 states. Ideally we wanted a clock whereby I can be able to choose if I want it to be in a stable state, I want it to be monostable, or I want it to be in bistable. Let me bring back the lights. So that is why we added these 3 chips. It's not very complex, because what we have from these chips is a very interesting concept, which by design I used so that to be able to get all the 3 inputs together. First of all, we have the 74LS04, which is generally a set of inverters. We have the 74LS08 AND gates, and 74LS32, which are just a bunch of OR gates. You really do not have to, if you're working on this project, you really do not have to use this all these 3 gates. You could choose to eliminate all these 3 gates and just use NAND gates. Because after all, design is just design, but at the end of the day, what matters most is whether you can be able to get all these 3 inputs together. So what do I mean if I wanted to choose which state my clock is? First and foremost, I want you to look at this LED. This is our final output LED. This is what shows exactly the speed of our clock. It is in sync with this LED, meaning that right now our clock output is in a stable mode. But what if I wanted my clock to be say for example in monostable mode? So if I want my clock to be in monostable mode, I could say, all right, how about if I just press this light? Yes, this light shows that this chip is in monostable mode, but our output is still in a stable mode. So what I do is I slide this switch. When this switch is slid now to the off position, when you press this button, now the clock picks up now what this chip is actually putting out. So now our clock is now, you can be able to control how the clock moves. If, say for example, you have an experiment whereby you want to see every bit by bit how it's being calculated or how it's being processed by the computer. Then you'd put the computer in monostable mode so that you could go step by step, second by second. You see exactly how the clock or how the computer is progressing. At this stage now, our clock is in monostable state. You have just moved from astable to monostable. Now, how about if I want my clock to be in bistable? Ideally, bistable means that it is either of the two. So if you put your clock in this mode, and this switch is now turned on, and each and every state that this chip goes into, your clock also takes up that bit. But ideally, I would think that because this is a computer, it can either operate between either two, that is the astable or monostable. But the most important part here is the speed. How fast or how slow do you want your computer to move? So carefully looking at the output LED, it's very fast right now, and now probably to be very slow. So this will be a very crucial component when, as the project grows bigger, as the project grows more complex. I'll be referring to this state or this video because it's a very integral part of the project. So that's all for now. I hope I've been able to clear up some misconceptions that you had about the clock, or generally what a clock does in a computer. Now, in the next video, we are going to go into registers, and that is where the fun begins. So this is the entire design. In the next video, I'll be able to zoom out so that you can be able to see how the register section is. We have the A and the B register, and then how they integrate together with the clock. So thank you for watching, and let's meet next time.